Hello, welcome back. Last time I learned some assembly and solved a few puzzles and had a great time. I seem to be picking all of the really polarizing divisive LPs lately because reactions to this were either, oh, this is awesome, or oh man, this is not going to make a good LP. I am currently on the side of the divide that says this is awesome, so I'm having a real good time with this right now. But it's funny that this is happening so often lately. It's fine though. Something I noticed though was rereading this. Uncle Randy died while he was using this computer. I think that's important to the story. I hope that I will not also die using this computer. Be careful, this could be deadly. Signal multiplexer. Create new program. Read values from in.a and in.b. Read a value from in.s. Write in.a when s is -1, in.b when... Oh. Alright. So we need jazz, jugs, and jills here. Okay, so... Right, in.a. Alright, so add them together if 0... Right, signal multiplexer, I get it. I understand what you're saying here. Oh, also there is a step button here, as it turns out. I just didn't notice it before, so that'll come in handy. Okay, so in.a, in.s, in.b. All right, so s determines the output. Out is here. Okay. So we definitely need to read from up. But where? Let's see, so what's the simple way to do this? Wouldn't it just be... I think a real simple way to do this would be... Start with that. I'm going to do like all my processing here, and this will just move stuff around pretty much. Oh, but I need storage. Oh, this is interesting. I need storage. Okay, so I need to read exactly each one of these per row. So I need to be sure that I'm not just like, basically like I can't just check, you know, if this is -1, just read this and shuffle it down here. If it's 1, just read this and shuffle it down here while doing, this, because then my reads would be misaligned. Like I have to actually actively discard a value from each of these. Okay, so I think this is where I would use back, right? So the back is use swap and save, right? Ack, back, sav, swip. Swip does that. Okay, so it's just issue that command and those are exchanged, or issue this command and this one's overwritten. Okay, so pretty sure that's what this is supposed to be tutorializing. Okay, so I want to actually no, it's not even that. I need to sure. Wait, hold on. Tell me about these. Okay, so that reads ACK. All right. Okay, so JLZ. So if it's -1, I want only this one. I should not call my label left. That would be confusing with those directions. JLZ read left. Yeah, I'll define it in a moment. JEZ read both. JGZ read right. I don't know if I'm going to have enough instructions in here to... this is going to be very inefficient, by the way. It's fine, though. I'm going to see if I can do all my processing here and just have these shuffle only. It should be possible, right? So that's my start label. Okay, so read left. You know what? I don't need this jump because either one of those jumps will happen or it will fall through. Okay, so this is read-write. Actually, okay, so move left. Now, am I remembering correctly that I can move to nil? Let's see. Tell me about ports. Nil, yes. Produces the reading nil, writing nil has no effect. There we go. Move left, nil. No, move right, nil. No, wait, this is read right. Move left, nil. Move right, down. Okay, read left. Move left, down. Here, let's move right, nil. Move left, down. I need some jump start. Jump start. I think I will have exactly enough instructions to be able to do this. Yes, it will loop back around to the start. So I'm falling through from here. If the jils and the jez fail, I don't need an explicit jigs because it'll just continue. Yes, this is how I'm pronouncing these. Deal with it. And when I get down here, I don't have to jump to start. It will just loop back around. So this program exactly fits in this core, if I've done it right. Tessellated intelligence system, many parallel cores. I am very much single-threading this multi-threaded system. Let's run. Check it out, I did it. That's perfect. Perfectly inefficient. I spent all day writing code, and now I get to do it some more in a different language. Yay. Okay. Everybody else did this exact solution. All right, that's fine. Cool. Sequence generator. Create new program. Oh, wait, hold on. I missed something important. Return to segment list. I did not even look at this. Compute node diagnostic, microcode dump. January 31st, 1980. I wasn't paying attention to those dates if they were there before. I might have an idea of where this TIS-100 machine came from. .0 described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. 0 at government project maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush hush top secret.fp. Maybe could I be in possession of a classified device? Something for spooks? I might have to sit on this one for a little WH9.0.R/dot. What has happened to your messages? They're all kind of semi-corrupted. 1994, 0305, my preferred date format. The new girlfriend is encouraging me to get rid of the microcomputers I've accumulated over the years. So 14 years later. Wait a minute, is there a date on this letter here? No. But, okay, so it can't be earlier than 1994, assuming this date is accurate. Alright, so March 5th, 1994. New girlfriend encouraging me to get rid of microcomputers accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one, though. Never found out what its whole deal was. And if it turns out to be something I wasn't supposed to have, I think I could get in trouble. Huh. Cleared a little space on the workbench and hooked it up. Still works. Beautiful. 44.R0. Yes, it is a beauty, this one. So was it around March 1994 that he died, I wonder? I guess I'll probably find out as this goes on. Alright, sequences are 0 terminated. What? Read values from in.A and in.B. Write the lesser value to out, write the greater value to out, write 0 to end the sequence? What are you saying to me? 46, 71, 0. Okay, so just write a 0 every 3. Oh. Really? Okay, so just basically do a two-component sort and write them in ascending numeric order and then write a 0. Okay. Okay, so you're getting in my way, kinda. I could get around you by, well, hang on. No, what do I want to do? Let's work, where? How? Well, I could move this down and use the, sorry. Kind of thinking out loud, but not saying at all what I'm thinking about. Is there a... Now, hang on. Didn't I implement a compare signal comparator? How does this work? No, this doesn't do that. Okay, so this is getting interesting. Something that would be absolutely trivial in a high-level language. It's a little bit less trivial here, but I think I understand how to do it. All right, so let's try this. So left is in.A, right is in.B. Once again, going to have all my work in a single core. So I want to do what here exactly? Move up, save, sub left. So, all right, so I've read the value of in.b. It doesn't matter which is which. I just need to output the greater, the lesser and the greater one. Oh, I need to output both. Oh. Oh, that's interesting. No, that's fine. That's totally fine. Okay, anyway, so I've read in.b and stored it away in back. Then I subtract in.A from it, and whether that's, what if these are equal? Then it doesn't matter. Then you just write the two equal values, right? Okay. So I've subtracted this from that. If I get a positive number, then just setting up some structure here. All right, so this is negative. This means that in.A is... Hang on, okay, so I'm subtracting in.A from in.B. Oh, wait, oh, shoot, this is... All right, so I saved that to back. I don't feel like I have enough registers for this. Hang on, there's a half-formed program in my mind. Can I get it fully formed and understand what's wrong with it? Because there's something wrong with it. Positive. All right, so if I have a negative number in my main register, in AC, then what do I need to do? I need to... write some values. Okay, so if this is... I have an... I need to save the value of... Okay, so I think I need to actually do this. I'm going to be reading this value twice here. Once to subtract and once to add. So sub left, JGZ positive. Let's try this. Yeah, okay, so this is cool. So this means that Man, this is real hard to think about. It's hard to keep track of which value is where. So let's go through it carefully. I read value B, and I save it away in back. Okay, B for back, A for ack. That works. So B is in back, A is in ack. Then I subtract, well actually A is not in ack. The difference is in ack right now. But if I just read that, then, dang it, positive. Positive means that the greater value is in dot B, right? Yes, because I have subtract a lesser number over here from a greater number over here. I end up with a positive result, which means that I want to write my brain's tying itself in knots here. I'm just trying to, this is one piece of information too many to keep in my head. I know what I want to do. I just, the specifics are hard to phrase. Do I want to do that at all? I'm not sure that I do. Okay, one more time. The value in back is the value of in dot B. When I have subtracted in dot A from in dot B and gotten a positive number, that means that I want to write in dot A first. Okay, so in the positive branch, I write in dot A to down. Yes, this is correct. Just going to do that there. Okay, so move left down, move swap. I think I am actually going to run out of space in this core. Okay, so negative. Oh wait, I don't need this. That will loop around, but I will need it here. I have it there already. Okay, so maybe I won't run out of space. So I'd want to do exactly this, but in the other order. So yeah, just like that. Okay, that should work. It's hard to adequately explain these things as I do them. Hopefully I kind of went through my thought process there, but when I run into a hiccup here and have to stop and think a little harder, it becomes much harder to talk about what I'm actually doing. So hopefully that made sense. All right, return to segment list. Good stuff. I got both of those first try, first run. They executed perfectly. Debug. This is called sequence counter. 1994, unknown date. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. I feel like I'm learning about the people behind this and their design decisions. The thoughts that went into figuring out how things should work. For those people feel very close to me now, Lee. Okay. Sequences are zero terminated. Read a sequence from in. Write the sum to out.s. Write the length to out.l. The length. Oh. So now I do the opposite, kind of. I'm reading the output of my previous programs, sort of. The length. Fascinating. Okay, so this is where I would use jez. Length to out.l, sum to out.s. Fascinating. So this is like a completely different format of that. Okay, I get it. So, where do I want to do my processing, and what processing do I want to do? Probably here-ish, and let's see how far I get with this. Okay, this is going to get real interesting. Right, the sum to out.s. All right, so I need to do a bunch of stuff. This might not be where I want to do my processing. I might want to reserve this just for output. Let's preemptively do that, because I think there might be some complicated stuff going on here. But But no, that doesn't make any sense. So, the internal processes of my brain when I'm forming the phrasing of a program are not conducive to being spoken, as it turns out. I understand what's going on, but not in words, in a different intuitive way of understanding. So, anyway, I definitely need to read a value from this. If it's 0, then I need to jump to the end of the sequence. So at the end of the sequence, see now this wants too many. Okay, I'm gonna have to get creative here. Actually, okay, thoughts are occurring to me. I'm thinking of something like, always write this value to this thing, then when this thing has read a 0, it accumulates the number of things it has read and writes that out there. Yeah, that sounds very reasonable. This program's looking an awful lot like this program. Okay, so if it's a 0, then... No, wait, I need to... Okay, so... but it'll make sense in a second. Alright, so I read one thing. I'm going to swap. Back does indeed start at 0. I might need to set it to 0. Sure, start there. Okay, right, so it's, that takes kind of a bunch of commands to do. All right, so I've put 0 into back. That's going to be important for resetting this. Then I'm going to loop here, move left into ACK. Add 1 to back. Swap again. This is fairly inefficient. Oh, right. That's an implicit operand, because that's the only valid target you can have. Yeah, I don't like this much, but it's okay. All right. And I do always want to add 1. No, false. I want to not add 1 when this happens. Okay, so I want to jez 0. I can cut and paste. I want to jez 0 here. So if a 0 has happened, I want to write a 1. All right, so... wait, but my loop should totally change back to 0. No, 0 should jump back to the start. Okay, no, this makes sense. I'll explain when I'm done writing this. Okay, that's fine. So what this does, this is going to expect... I always want to move this to there, because this does need to read the zeros. If I have also read a 0 here, then I want to... Oh, I need to write the sum. Okay, so this is half the program here. And this is enough to allow this half of the program to execute. Okay, so what I've done is... I've had this core read the value of in. When it reads it, it's not particularly interested in what that value is unless it is a 0. But every time it reads a non-zero... Yeah, okay, so this will basically do nothing on the first run. So ignore that, more or less. So if we're doing that, then it'd be more efficient in theory to do this. Sure. Okay, so start in the base state. Loop is this label. I read the value of in. If it's a 0, the value of back will be 0 at this point. It starts at 0, so I don't need to initialize it at the start. I read a value from in. let's assume it's not 0. I add 1 to back. So swap, add 1, swap, adds 1 to back, whatever that value is. And then I go back to loop and keep on reading and keep on doing that until I run into a 0, at which time I jump over here and read the value of back into ACK and write it to out.l. So that's the length. Then I reset to the value of back and go back to the beginning loop. Okay, so this half of the program from reading over it seems correct to me. The other half of the program needs to sum numbers together. Okay, so the value of your back is going to be the sum of these. All right, that sounds very reasonable. Jez seek end, that's fine. So seek end is just move ACK down. False. It's swap, then move ACK down. All right. Oh, and you also need to initialize back. All right, so I save that. So in here, what needs to happen is add ACK to back. Oh, how the heck do you do that? I think it's going to have to involve this. Oh, this is cool. I probably can't do that, but why not? Because this will execute atomically. This means nothing, probably. It doesn't complain about it. Like, there is no register involved here. This doesn't, no, this doesn't, like, execute the read and then hold that value and then spit it back out, probably. Yeah, because it needs to block on this for a moment, then block on this. All right, so UR storage. This is how this module turns into storage. There are more modules I'm going to get eventually. I peeked ahead in the manual. T20 reserved. I'm working with T21, basic execution node, but more will be showing up. There's also stack memory node, random access memory node, possibly some other stuff. Anyway, so UR storage. You are an extra register for you. So what's going to happen here is, what was I using that for? I've already forgotten. I'm sure I will re-derive the same conclusion and be happy that I set this up. All right, so if it's 0, then we write back to out.s. But when it's not 0, I need to add ACK to back. That's right. Okay, so I need to... I think I need to move ACK left, swap, add left, swap, right? And then jump start. Or jump loop. That thing's pretty full. That program barely fits. Okay, so anyway, read in. Shuffle it over here as necessary. Use this as storage. Okay, so if it's a 0, then do your thing. But while it's not 0, use this as storage, an extra register, swap to back, add this to it, swap back to back to back, swap ACK back to back, and then continue the loop until you hit a 0. Then you get to seek end, swap back in, move it down. All right, looks good to me. This program is slow. It's working though. My cycle count's gonna suck. But hey, once again, I phrased my program correctly. First run is perfect. Nice. This is very satisfying. Boy, this game's real good. Kinda tempted to try and optimize this. Because yeah, my cycle count is above average. Node count is below average. Instruction count is average. Okay, cool. All right, great. Well, you know what? I'm going to be happy with that. Even though that's 2 above average, that's 1 below average. So on average, I'm a third above average. And above is bad. I'm going to be below average. I'm saying a lot of words. I feel like so many of them don't really mean anything when they actually come out of my mouth. But hey, I know I had a good time today. This was super cool. I'll see you next time for Signal Edge Detector.